Okay, so thank you, Prof. So I think now we can proceed with our last lecture entitled Agreement Analysis and Kappa. Thank you.
Okay, thank you very much, Mr. Chairperson. Okay, this last part, I know I'm going to lose most of you because, okay, first and foremost, just to make everybody become comfortable, just take note this agreement analysis is put in because of requests from pathology department and radiology department. All the other departments are not going to use this at all, so you can go and look for your lunch because you are not going to use this. This one is only for radiological department and pathology department. That is the only reason why this lecture is put in. Okay. So this is something that you don't have to worry about. Okay. The last time this is one of the topics that I like to tai chi to someone else. You know what it means tai chi, and just the word come pass to someone else. I don't like to do this topic because it is quite difficult to explain. It is quite difficult to explain, and especially in this group of clinical students, clinical postgrad students. It is easier to explain for the epidemiology class because they already have all the grounding lecture or all the foundation related to this. Okay, so it is not an easy topic to cover for you all. But I will do my best. I will do my best. And I will start by changing my background first from my gambar ASK. I know kejap lagi kan Khaidi akan bising, Dr. Azmi kenapa tak tukar background? Ada kejap. Okay, I was supposed to use the other background. The other background is at the bottom. This background. Sorry. Somehow this one does not look so well because what happened, the green screen, this area down here is not well lighted. By right, we should be using external lights. So that's why it looks horrible. Suddenly my hand got macam berantu, glowing green at the side. Okay, so let's get the PowerPoint up. Okay, this is the end of the torture for you all. Also the end of the torture for myself. Okay. The pain is going to end soon, so just bear with me. Kesakitan akan berakhir kejap lagi, jadi mohon bersabar. Okay. I'm going to share the screen now. Share screen 2. I saw the video, so I know there's not much difference. When I click share, gambar macam sama je. But except for the difference at the top right side, there'll be a small video of myself. Okay. But at least this way, I get a bigger picture of me. I'm big, 107 kilogram. But here on the Zoom, I'm bigger. Okay. Maybe I should take a photo of this. Me being a big size. Okay. Okay, something to share on my FB today. Me being big size on the computer and screen. All right. Okay. So just take note, okay. This thing is something that will never be done for most of you all because most of you are going to do clinical trial or maybe cross-sectional, sometimes just case control study. Currently, the only group that is doing cohort study is the pure group, pure Center for Prospective Urban Rural Epidemiology Study, and the Malaysian cohort group. Okay, those are the only cohort study. That's why I was surprised that day when we did the survey, a large portion of you answered cohort study. Okay, I do not know where we have gone wrong during the lectures. So this part of the lecture is specific only for this group. for those doing diagnostic testing like radiology department and pathology department. Okay, so inside this agreement analysis, we are going to cover about by right lah, we're supposed to cover sensitivity, specificity, and receiver operator curve. But since my topic is only for Kappa and agreement study, I'm just going to cover that. Okay. So usually for the people from Petto and logistic and Petto and radiology department, whenever they come to see me asking about this, I tend to just give them a set of articles for them to go through and for them to correct their proposal accordingly. Okay. Still got 102 participants, okay lah. I thought most of you will have left already. Sebab Petto dengan radiology, I think there's about 20 of you only. Okay, let's look at the clinical agreement and reliability analysis. Okay, so usually you have a test, your X-ray, your CT scan, your echocardiogram. According to my echocardiogram, it says my ejection fraction is 0.6. I can't remember exactly. Something like that. So all these tests helps in the doctor in managing their cases. Okay, so whenever you look at the test, the results, we look at the validity of the test. How good is the test to identify the sick and healthy individual? Right now, the most contentious results of the test is the PCR for COVID. Masing-masing bila kata negatif, positif COVID, semua kata betul ke test tu? Boleh percaya ke result tu? Aku rasa okey je. Yalah, of course, 90% of us who are infected by COVID do not have any symptoms at all. They are quite happy, asymptomatic. Only about 10% are suffering badly from the infection. Okay. So, reliability, how stable is the result of the test? If you do the PCR now, then you repeat again, mula-mula positif, negatif, then positif. What? So, susah lah kan? So that day there was argument. PPUKM do the test for PCR, got positive. Hantar dekat KKM kata negatif. Lepas tu patient discharge. Lepas tu things look very bad for us. Yeah. So how stable is the result of the test? Is it repeatable? Is it the same? And of course, efficiency and cost effectiveness. Kalau jangan marah, aku bagi contoh tu. Okay. So how to measure? Okay, how to measure. So we are going to discuss about this one already covered partly by Prof. Isanaina about accuracy. Okay. He also covered about reliability. So I'm just going to cover only on the test. Okay. So how to measure accuracy? That one we do sensitivity and specificity. Okay, this one not covered by any of the speakers during this talk. Somehow it was thought not to be required, not to be important. So instead, we're going to talk about agreement analysis. So agreement analysis in the sense that we will look at reliability. So if the thing is for qualitative analysis, we're going to look at Kappa statistic and AC1 statistic. If it is for quantitative data, we're going to look at the Blunt-Elfman plot and the Cronbach alpha coefficient. Okay, so I know Isanaina covered at length about reliability. I know he has covered a lot of things about saying that if it is not reliable, it is not valid, and so forth. I'm not going to cover that part since it has been well covered by Isanaina. Okay, I'm just looking at the statistical test part. Saya hanya melihat pada ujian statistik. Okay, so okay. Already got question. Must be very good topic to have suddenly got question already. So early. Okay. So there are things that we look at the reliability of the test. If there is only one observer, if I look at something, the same thing again and again, do I see the same thing or different? Or between I and Fitri, we are two different persons. We look at one result. Do we have the same interpretation or is it going to be different? So intra-observer, myself, I see the same thing again and again. Do I come up with the same conclusion? Or inter-observer, when you have more than one observer, you have end up with the same observation. Example is interview student masuk medik. You got two interviewer. Okay. So one interviewer say, oh, this is a good student. I want him to enter medical school. The other one say, no, useless one lah. We don't want this kind of people. Okay, we got the inter-observer variation. Then the other one is repeatability or reproducibility. How stable is the results if it is repeated many times in similar condition and situation? Okay, so how do we measure reliability? So as mentioned just now, we got Kappa analysis, we got Kappa, we got AC1 statistic, we got blunt element plot, Cronbach alpha coefficient, intra-class correlation. Okay, these are advanced topics because the only thing that usually taught is only Kappa lagi. Macam nak kepak ayam lagi. The only thing that we always taught is just Kappa analysis. Okay, the rest were rarely taught. But since I'm teaching advanced statistics class, we cover all these topics on a regular basis. Okay, but in the normal classroom, it is the only thing that is usually covered is just Kappa analysis. Okay, let's do a Kappa analysis. Okay, here's an example where we have examination of the same 100 fundus photograph by one clinician. Okay, there's going to be a problem here. I know you cannot see the top part because for me it is also covered by the control bar. The last time I play around with this, I end up losing everything. Let's see whether I can cannot bring out. Sorry. Okay lah, mampu dia lah. So agreement between two exemptions of the same 100 photograph by one clinician. Okay, one person. I look at the 100 pictures. First round, I give my result. Then I do again the same thing. I do again. Even I cannot agree with myself. You see? Even I cannot agree with myself. Kat mana tak agree? You can see here. First round, I say moderate. Second round, I say little retinopathy. Okay. First round, I say this one got little or no retinopathy. Second round, I say got moderate. Okay. Doctor, is this same like Magnema? Yes, it is similar like Magnema. Table similar like Magnema, but here we are not interested in Magnema. We are interested in measuring the agreement. Okay, same table but different analysis. Oops. Rasa baru makan nasi lemak, dia lapar balik. Must be lunchtime already. My wife said, I'm always hungry because maybe I'm diabetic. I hope not lah. Right now, nowadays we daily checking my blood glucose level. So because of that, now daily I have to cycle. Okay, so now we got another scenario. So another scenario, we got two different person. Okay, first clinician Azmi, second clinician Fitri. We look at the same 100 photograph. Lagi tak agree. Lagi tak agree. The more the disagreement. Okay, so moderate or severe retinopathy. I say moderate or severe retinopathy. Fitri say little or no retinopathy. I say little or no retinopathy. Fitri say moderate or severe retinopathy. So there were out of 22 out of 100 that we did not agree upon. So when we see like this new scenario, then we do the Kappa analysis. We see the level of agreement. So you can see here, okay, this is, first we look at the observed agreement. So I and Fitri only agree 78% of the time. Okay, why 78%? We got this one 46 we agree upon, and here's 32 that we agree upon. So 78% we agree. So look at that one is observed agreement. Then of course we have to see what is the expected agreement. So expected agreement, okay, this is where the trouble comes. Okay, how do we calculate expected agreement? Okay, don't worry, that one is in the next slide. Okay, so what is the expected agreement for all the portion? And please take note, okay, this one all comes up to 100. Okay. Okay, you have angguk, geleng. So observe mild severe. Okay. So you have again the angguk, geleng. So 58 times 56 divided by 100. Then you have the next one, 44 times 58 divided by 100 and so forth. So that's how you get these values. Same like chi-square. Same like chi-square. So that is how you get the expected agreement. So the expected agreement, based on that, angguk, geleng, is supposed to be 32.5 plus 18.5. So you end up with 51%. So, but therefore, they expect if the agreement level between I and Fitri is supposed to be 51%. But now we got 78%, which is good already. Which is better. So this is observed agreement O, this is expected agreement C, and this is actual agreement beyond chance. Okay, so therefore, based on that, you put into the formula actual agreement beyond chance, which is 78% minus 51, divide by potential agreement beyond chance. So potential agreement beyond chance is 100 minus 51. So 100 minus 51 is 49. So therefore you get a kappa of 0.551. Sorry. That's guess. So we have this table of kappa values. So just now, as you can see, agreement between me and Fitri is 0.551. Okay. So 0.551, it is here, moderate agreement. So I and Fitri were in moderate agreement with one another. Okay. All right. Okay. So sometimes, okay, they don't use the other table, this one. Okay, Dr. Azmi, where can get this table? Dekat Wikipedia je. Dekat Wikipedia. You look under, there's two kind of agreement. There's flash kappa and coherence kappa. You can check them both. Some of them use this one. Some use the agreement analysis using R method, which is not that common. Okay, this is much more common. Okay, can we do it in SPSS? Yes. Okay. Don't tell me, are you paid for by SPSS? No. But I was responsible for bringing SPSS into UK Medic way back in 1997. But of course, we started using the illegal version rather than the legal version. Then we found out that UCAM already have the legal version, so we started using the legal one. Can you all get the legal version? Cannot. Sorry. Okay. So under SPSS, just click on Kappa and they will give you the answer. Okay, here when I do the same analysis using Kappa, just now we did the manual agreement, the value was 0.551. So when we did the p-value is very significant. Okay, but of course I already told you earlier, for Kappa we don't care about the p-value. We look at the value of the Kappa, we interpret based on the value of the Kappa. Okay. Sometimes Kappa cannot be used. Why Kappa cannot be used? When the outcome is very small. When the outcome is very small. Okay. When one of the category in agreement is low, the Kappa value is artificially low despite the high agreement value. For example, the one given in the table here, okay, you have the agreement for one part very high, no disease 85. The one with the disease very small, 5. Okay, so you can see agreement level here is 90%. Observed agreement is 90%, but because of the small value, okay, you cannot use Kappa, because when you use Kappa, you end up with agreement level of only 0.444. So instead, what you should do AC1 statistic. You should do AC1 statistic. Sorry. Okay. Basically, my battery is running out. I'm looking at the wrong thing. I'm clicking on the wrong thing. So this is a formula for AC1 statistic. Okay, I need to move. Yeah. There's a formula for AC1 statistic. The camera is auto tracking. So very sorry. Okay, I'm going to hide myself. Okay, let's hide me. Jom kita sorok diri kita. Studio mode. I'm going to hide myself. Okay, so you can see the formula. Okay, AC1 statistic equals to this value divided by this value, and this value P is A plus D divided by N. So A plus D divided by N. Okay, then this one is this value. Okay, but for the Q, you have to get the A1 and B1. This is the A1, this is the B1, this is the 2N. So you have to calculate this manually. Why you have to calculate this manually? SPSS tak ada. SPSS tak ada. So here you can see instead of getting the Kappa of only 0.444, you end up with AC1 statistic of 0.878. Okay, this is more consistent with the two raters having the same rating of 90% of the subjects. All right. Okay. So, and that is the explanation. Okay, right now I'm looking for my cursor. My cursor is missing. Okay. Okay, I'm back. Okay, let's go to the next one. That is AC1 statistic. Okay, so we already talked about Kappa. So Kappa can be used for category data, but if one of the group is very small, one of the outcomes is very small, then you have to use AC1 statistic. So after that, we have to look at quantitative data. Quantitative data, you got 3. You got blunt element analysis, we got ICC, we got Cronbach alpha. Okay, let's go and see. Okay, doctor, just now you showed us Pearson correlation. Why we cannot use Pearson correlation? Can, but you have to understand the correlation by right is not a measure of agreement. Correlation is a measure of relationship between two variables. Okay, two different variables, the height and the weight. If we're trying to show agreement, you cannot use correlation. And you also cannot use a PET test. Okay, you cannot show a PET test. Okay, why? Okay, if you use correlation, both got the same correlation. Both got the same correlation. But the problem now, this one started at a higher point. This one started at 0. Okay. Doktor kacau. Okay, saya try gerak. Nampak? Dia tak dapat kat 1. Dia tak dapat kat 0. Okay. Dia tak dapat dekat 0. So that is why you cannot use correlation. You may have the same high correlation, but the one that shows agreement was the one on the right side, not the one on the left side. Okay, so instead of doing a correlation or doing a PET test, you do what we call a blind element plot. Blind element plot describes agreement between two quantitative measurements. There is no p-value available to describe this agreement, but it is rather a quality control concept. Okay. In all of my life here in UCAM, the one and only time somebody asked me about this blind element plot is someone from pathology department. Okay. So what I'm telling you, don't worry, you're not going to use it. Okay. So the difference of the two PET, the PET2 measurement is plotted against the mean of the two measurements, and it's recommended 95% of the data points should lie between the plus minus 2 standard deviation of the mean difference. Okay, so it is a matter of plotting. So how I did it? I did that using SPSS, but it requires a lot of calculation and what we call computation and transformation to calculate. Basically, what happened was, this is an example given here. It's between two different instruments to measure temperature. Remember the temperature, you go to the kedai makan, you kedai makan, ada orang pegang tangan, ada orang letak dahi, ada letak mulut, whatever. Okay, so then you have the correct one which you take and put under your tongue. Geli. So people are asking me, Dr. Azmi, what is the most accurate measure of body temperature? I said the most accurate must be from the central body. To measure the central body, you have to put it up your ass. So of course, nobody wants to go kedai makan cucuk thermometer kat situ kan. So that's why we have to make do with the thermometer yang gunakan infrared. Okay, so that is the best compromise that we can do for. But if we do the measurement agreement, we find that this infrared one not so accurate. Yeah, the infrared one not as accurate as the one put under the tongue. Okay, you can see here the agreement is the correlation is 0.871. Okay, so 0.8 looks good, very strong. Okay, but when we do the blind element plot, that's when we realize that the dots are everywhere. So you can see here what happened is we use the formula A minus B, and then A plus B divided by 2. Okay, then we look at the differences, and then we look at the average. In fact, the A plus B divided by 2 is the average. So you can see here the temperature at 37 degrees Celsius, our normal body temperature, okay, is everywhere. The difference can be up to 1.5 Celsius, 1.5 degree Celsius. Okay, ada seorang pakcik tu sampai 39 degree Celsius. I think this one memang COVID case tu. Alright, so whatever it is, I'm just trying to show you that this thing could be a problem. Why is it a problem? Okay, because you just show that the high variability between of the two instruments in measuring temperature. Okay, and this large deviation could be either flaw of the instrument. Maybe instead of taking the temperature using the forehead, the person uses his hand to check the temperature, or could be operator error. Okay, because maybe the machine is under the sunlight. Okay, in McDonald's dekat Bukit Subang, the night alarm, the thermometer is at the front door, and the front door is under the sun. So if you come at around 38, you come around afternoon at 1 o'clock, everybody is going to have temperature above 37. Okay. All right. So that is the issue here. Just to take note. So blind element plot is a good way of measuring the accuracy or the agreement between the two instruments. So how do we interpret? We look at the 2 standard deviation. How many dots are above and beyond the 2 standard deviation? How many dots are between the 2 standard deviation? Between the 2 standard deviation, we are okay. Acceptable differences. If it is too far away, then somewhere okay, Houston, we are in trouble. Okay, Houston, we have a problem. Okay, so here this one we have a lot of problems. 1, 2, 3, 4, 5. This is our Apollo 11. Oh, sorry, Apollo 13. This is our Apollo 13. They are all very wrong. Okay, these are all. So these are the 8 data set that is beyond the. So is it important? The difference is 1.5 degrees Celsius. So you tengok, kalau 1.5 degrees Celsius can make difference. Someone have COVID or don't have COVID. This is how we decide lah. But my wife that day, she went to the bank. The girl said, "Oh, my wife's temperature is 28 degrees Celsius," and she did not allow my wife to enter the bank. Bloody hell! Come on lah, 28 degrees Celsius, something wrong with your machine lah. Not something wrong with my wife. Okay, here's the example that I showed on how to do the blind element plot. Okay, basically they just showing we got 2 machines. We got a Mercury and we got electronic BP set, and we check and we get the mean and we get the difference. Then we plot accordingly. So this is how we do it: get the mean, then we get the difference, then we plot it accordingly. Okay, how we plot? We use a scatter plot, and we got a table looking like this. And this is how we check for agreement using the blind element plot. Okay, as you can see, most of the BP are okay, but some of the BP lari gila babi, 25 millimeter hydrogen. Okay, so for your information, I still have the Mercury BP. I just realized under the Malaysian law, and we are not supposed to keep the Mercury BP set after the year 2008. 2018. Now it's 2021, 3 years already. I still have the Mercury one because the Mercury one is accurate. My electrical one, whenever I don't trust the electrical one, I take my Mercury one. My wife very unhappy. I kept the Mercury one. My wife is a biochemist. All right. So that is the agreement, and we talk about blind element plot. The other one is by looking at tolerance. Okay, between the 2 machines. So we look at the difference, whether there's acceptable tolerance in terms of the differences between the instruments. That is how another one of looking at the tolerance. Okay, so we covered blind element plot. We covered blind element plot. We covered tolerance. We are going now towards the end already. Okay, we got Chromebook Alpha and ICC. So Chromebook Alpha. Okay, this one, if you are doing questionnaire, you tend to have to do a lot of Chromebook Alpha. Okay, so you got items, you got questions, you do quality of life. You want to see whether your questions got reliability, got internal consistency. you do a Cronbach alpha coefficient. Okay, it is used to measure internal consistency. The value should be above 0.7. Okay, how you do it inside SPSS? Just click Analyze, Scale, Reliability Analysis. Select the two variables that be compared and move them into the box marked items. Then you select from alpha, then you run analysis, and you get answers. But of course, usually we don't do only for two items. We do for many items at the same time. So your questionnaire quality of life got 36 items. Why 36? Because you call it the short form SF36. So based on the 36 items, you put it inside the Cronbach alpha. You run the analysis and then you check for the alpha. Okay, for this example, I showed the data came from the BP measurement from two different sets, a mercury manometer and the electronic BP set. Okay, which is okay. So I'm going to show it to run. So you can see here, we have a Cronbach alpha of 0.9694. So we are okay. We are okay. So Cronbach alpha is quite high, very high internal consistency. Okay. So 94% of the points are within plus 2 standard deviation. Yet some of the readings differ up to 25 metahydrogen. Yet the Cronbach alpha says it is there is internal consistency. Okay. So you have to be very careful how you want to interpret this accordingly. Okay. All right. So in short, use of which reliability analysis depends on the type of data being analyzed. Some reliability tests require subjective judgment during interpretation. Okay. Doktor tak sentuh ICC. ICC is GLM. You can check my notes on GLM on the website, then you can do it yourself. All right. Okay. Thank you.
Thank you. Thank you very much, Prof. So we do have two questions. The first is from Dr. Chin. My research is about comparing among different stages of AKI, which is AKI stage 1, 2, and 3. Kruskal-Wallis shows statistical significance. When I proceed with the Wilcoxon rank sum test for the pairwise comparison, do I need to divide the p-value of significant to be 0.05 divided by 6?
Yeah. Okay, I just repeat back because just now what happened, I was still trying to shut down my screen. And you may have missed the question. Allow me to. Okay, first, let's make Friday happy and put up the background of the medical research week. Okay, I just repeat back the question. Chin Jianwei. My research is about comparing the length of stay in ICU among different stages of AKI. Above ni, okay, acute kidney injury. Okay, thank you. Acute kidney injury, okay. No acute kidney injury. Acute kidney injury stage 1, stage 2, stage 3. Okay, Kruskal-Wallis shows its statistical significance. Okay. Okay, a very good question by Chin Jianwei. Basically, he's asking about the problem of the alpha error. So the alpha error, okay. The alpha error is basically when you do multiple comparison, there's issue of the alpha error, whether it is it should be reduced by dividing by number of comparison. Okay. Okay. I'm a bit hesitant to answer this because the scenario where we divide the comparison is something that we reserve for the ANOVA method of analysis. I have never done that for the non-parametric one. So I'm not really sure whether it is feasible or possible or should be done or not. Okay. The problem of the length of stay, it is surely will be non-parametric because most of them will stay for a short while. Very few will stay for a long term. That's why you end up with a not normal distribution of the length of stay. Okay, so for me, I will if you have proven that the length of stay is different, I would just do I would just calculate the median and the IQR for each group for the no AKI, AKI stage 1, AKI stage 2, and AKI stage 3, and present as such. Okay, and I leave to the readers to make their own assumption. The difference is where. If you do the Wilcoxon rank sum test for pairwise comparison, I will present them separately. Means I present them not as a group, but I present, okay, this one is a comparison between no AKI and stage 3. This is no AKI and stage 2. This is no AKI and stage 1. So I present them separately, not together as a single group. If I understand the problem of the p-value and the problem of the alpha error, okay? Because I'm not sure whether you can divide the p-value for the non-parametric one. I only know it is usually done for the parametric. The adjustment is usually done for the parametric. Okay. For I hope that's clear. I cannot answer more because we have never done for non-parametric. Okay. Okay.
Next question is, can you explain how to get the expected count? Thank you.
Angguk, geleng-geleng. It's the same like the chi-square. Same like the chi-square. So when you you look at the total of the, okay, I think I'm going to show you the slide again. Okay, let's see. I'm not going to use the normal way. I'm just going to share directly. Angguk, geleng-geleng. Angguk, geleng-geleng refers to, okay, you look at the sum. You look at the sum. 50, you see, okay, I'm going to put my cursor on the mouse. So you can see here 58, 56. So 58 times 56 divided by 100, then you get 32.5. Okay, this one, the 22.5 is 58 times 44 divided by 100. 23.5 is from 42 times 56 divided by 100. 18.5 is 42 times 44 divided by 100. Okay, angguk, geleng-geleng. Okay. All right. Okay,
Okay.
thank you very much.
Okay, thank you very much, Prof. Azmi. So I think we have no more questions. So we would like to thank for your presence today. So we will meet again tomorrow. So we want to share the QR code for the feedback form as well as for the MA MMA. Okay, thank you.